So as is given here, the reciprocal of a number is 1 divided by the number. Practically, for the fractions here, that means that we're going to flip that fraction upside down. The numerator will become the denominator, and the denominator will become the numerator. Really, this is also happening with the integers, like 2. Any integer is really a fraction with a denominator of 1. So to take the reciprocal, we'll simply flip the numerator and the denominator end for end. So the reciprocal of 2, or 2 over 1, becomes 1 over 2. You can also see that this is the same as taking the integer 2 and taking 1 and dividing it by that integer. So the reciprocal of 2/3 is 3 over 2. The reciprocal of -1 over 2 is -2 over 1. But we know that if we have a denominator of 1, that we don't need to write it. So the reciprocal is simply -2. This one, because it works out to a nice fraction, we can think of in those terms. 0.25 is really 1/4. And the reciprocal of 1/4 is 4 over 1, or just 4. Start at the beginning with order of operations so that we're all clear on how we're going to treat numerical examples, and then we'll be comfortable by the time we get to algebraic ones. You may know a number of different acronyms for order of operations. I'm going to use BEDMAS, but maybe you know PEDMAS or PODMAS or even GEMMA. They all mean the same thing. For BEDMAS, we know the B to stand for brackets, but what we really mean is grouping. We're going to perform any operations inside groupings first, and groupings can include parentheses that are square, that are round, they may be absolute value bars, and groupings include fractions as well. Numerators are grouped separately from denominators. E stands for exponent, which means we're going to evaluate any exponents before we do D, M, A, or S, so division and multiplication for D and M, and these are best performed left to right. If in doubt, performing division and multiplication as you encounter them left to right in an example won't lead you astray. And finally, once we've performed these operations, we can add or subtract. Again, moving from left to right will keep you out of trouble, although I'll also show you where each of these can be broken. So there's an example down here that we'll get to again. Be careful, it says watch out for a reason. We'll see this, I see many errors like this when we get to algebraic examples. Because the 2 and the 4 are grouped in the numerator, we have to add those first, even though addition and subtraction should come last. But here we have to be very aware that a fraction indicates grouping. I know that in a numeric example, you won't ever make this mistake, but it's a very easy mistake to make if I substitute those 4's for x's. Let's see a couple examples. All right, we've got a whole series of brackets. We have both square brackets and round brackets. I'm going to go to the innermost brackets first. So I'm going to recopy everything until I get to the 1 minus 2 inside the brackets, ignoring absolutely everything else we've got going on. Okay, we're going to subtract what's in the brackets, and 1 minus 2 is, of course, -1. All right, so I'm done inside the round brackets, but now I'm going to work inside the square brackets. I'm to take 1 and multiply it by 4, and also take -1 and multiply it by -1. -1 times -1 is +1, so I'm going to go ahead and show that multiplication first. So we have 5 minus 2 times 1 times 4, and I could have gone ahead and multiplied 1 times 4, that's just 4. And then -1 times -1 is +1, so inside the square brackets, we're left with 4 plus 1. Of course, we need to finish up inside those brackets before we do anything else, so we have 5 minus 2, and then in brackets, we're left with 4 plus 1 is equal to 5. All right. It's tempting sometimes, especially in an algebraic expression, to take the 5 and subtract 2 from it, but of course we have to perform multiplication before we can do addition or subtraction. Writing a number next to a bracket really just means multiplication, so we're going to take our -2 and multiply it by 5. So we're left with 5 minus 10. Finally, we can perform that subtraction. 5 minus 10 is -5. I'm talking through this example and writing a lot of steps. It's very possible that you're writing far fewer steps than I am, and that is absolutely okay. You may also be thinking about it ever so slightly differently with the vocabulary that you're familiar with. Let's try another example. So we have 16 divided by 2 to the power of 3 times 3 minus 3 to the power of 2. And again, sometimes it's tempting to pick apart the pieces that we're most familiar with, like 16 divided by 2 or 2 times 3. But we have to be very careful, once again, to follow the order of operations. This time we have no brackets to work within, so we're going to move right on to the E, which stands for exponents. So I'm going to take 2 to the power of 3 and 3 to the power of 2 and evaluate those. Notice that there's a difference between negative 3 to the power of 2, the way it's written here, and negative 3, all in brackets, raised to the power of 2. And we'll look at that when we look at properties of exponents. Here it's just the 3, not the negative, that's raised to the power of 2. All right, so if I evaluate the exponents, I get 16 divided by 2 to the power of 3, which is 8, times 3 minus 3 to the power of 2, which is 9. It's not a common usage, let's say, to write the division symbol as the division symbol. It does lead us sometimes to make errors. So here we just have to read it from left to right to ensure that we're evaluating this expression exactly as it's intended. So we have 16 divided by 8. 16 divided by 8 is 2. So we're left with 2 times 3 minus 9. And then we'll do the multiplication. 2 times 3 is 6. And finally, we're allowed to do that subtraction. 6 minus 9 is negative 3. Once again, you may have done this in 2 or 3 steps. I would like to see some of your thinking, but you don't need to write down as many steps as I have. All right, let's tackle one more. Okay, so we've got negative 2 being multiplied by negative 6, so we have a multiplication there, and we have our first grouping. Those straight brackets, maybe they look like straight brackets to you, those are absolute value bars. So a quick tour on absolute value over here. Absolute value just means how far away are you from 0? So the absolute value of, let's say, negative 4 is 4 because it's 4 steps away from 0. It just happens to be in the negative direction. Similarly, the absolute value of positive 4 would also be 4 because 4 is still 4 steps away from 0. We have to be careful here if we have something like negative, the absolute value of negative 2. If we treat these as brackets, if we consider them as negative times negative 2, we would very rightly say that that's negative 1 times negative 2, which is positive 2. Here we have to evaluate within the groupings within the brackets first. And the absolute value of negative 2 is positive 2. So this negative 2 turns into a positive 2. This negative sign is still there. And our final answer is, in fact, negative 2. So be careful with absolute value bars. Okay, that takes us back to this problem. So we're going to sort out what's going on inside here first. So what is 8 divided by negative 2? Well, 8 divided by 2 is 4, and positive divided by negative is negative. So we get negative 4. So what we're actually looking for here, I'll write up, is the absolute value of negative 4. We can go ahead and do the multiplication out front. It doesn't affect what's going on inside the brackets at all. So I'll do that next. And negative 2 times negative 6 is positive 12. And then I'll add, here we go, the absolute value of negative 4, and the absolute value of negative 4 is 4. And finally, 12 plus 4 is 16. Let's look at another series of examples just to make sure that we're comfortable with this. If it's been a while since you've done examples like this, it's a very valuable exercise to try some practice problems. Here, because we've got fractions in each of the 3 cases, we have to think of these fractions as groupings. So we'll do everything in each numerator first, followed by everything in each denominator, and then we'll worry about any of the division given, the fact that that fraction line actually means division. But because we have to deal with groupings first, even if we have addition and subtraction within one of those groupings, we'll do that before we get to the division. All right, this has gotten a little bit full. What do we have going on in this first one? Well, we have 8 times negative 3 plus 5. 8 times negative 3 is negative 24. And then we'll add 5 to that. While we're at it, we can work on the denominator. 2 times 3 is 6. So we have 6 minus 1. Again, I'm separately thinking of the numerator. We're thinking of the numerator separately from the denominator. Negative 24 plus 5 is negative 19, and 6 minus 1 is just 5. It's a little bit tidier to write the negative sign out front. So you have a negative only in the numerator or in the denominator. That's the same as the entire piece being negative. So we prefer to write it this way, but this would be absolutely fine as an answer as well. Recognize that a third way that we could write this answer is positive 19 over negative 5. But leaving the negative in the denominator, while it's technically correct, just looks a little bit ugly. So my preferred answer is this one. We're going to leave everything as a reduced fraction at this point, unless you're told otherwise. And that's kind of a math thing. So because you're in a math course, unless you're told a certain number of decimal places, leave your answers as fractions. Let's try another one. All right, so over here, looking at the numerator of 2 minus 5 times negative 2, and of course this could have been written as 2 minus 5 times negative 2 with the 5 and the negative 2 right next to each other, or even a dot in the middle. We need to be comfortable with a number of different representations for the same thing. So multiplication comes before addition or subtraction, so we have 2, all right, we'll leave that out there, and negative 5 times negative 2 is positive 10, so we're left with 2 plus 10. In the denominator, I'm going to work inside those brackets first. Inside these brackets, I can't do anything. It's just a negative 1, but inside these ones, I certainly can. And 3 plus negative 1 is the same as 3 minus 1. So we have 2 times 3 minus 1, or 2 times 2. All right, in the numerator, 2 plus 10 is 12. The denominator, 2 times 2 is 4. And finally, 12 divided by 4 is 3. Essentially, we're reducing 12 over 4 to 3 over 1. But if we've got a 1 in the denominator, we never write that in our final answer. And as always with these videos, you're going to have me encouraging you to try a problem before I get started on it, and then we'll see if we have the same answer. I encourage you to try that with this particular problem. Okay, so inside the brackets, we're going to work on that first, and then we'll worry about that multiplication. I'm going to write that multiplication just by having the 3 next to the brackets. 5 minus 3 is 2, and then we'll add 5 and subtract 2. It won't hurt anything if you go ahead and do that subtraction of 5 minus 2, but it's safest to go left to right, so I'm going to hold off. So here we have 6 minus 8. Plus 3 minus 1 is 2. That got a little messier than I like. I hope you're still following. My apologies. Working through the numerator, 3 times 2 is 6, plus 5 minus 2, and the denominator is 6 minus 8 plus 2. Maybe you've gone ahead and written the final answer already, and that's just fine. So hopefully you can see here that if I had taken 5 minus 2 at the beginning and rewritten that as a 3, we'd get the same final answer. So 6 plus 5 is 11, minus 2 is 9, or 6 plus 3 is also 9. So you can get there in multiple ways. The lesson here is that as long as you keep the sign with the integer, so the 2 must be negative, the 5 must be positive, you can reorganize them and do them in a different order. You don't have to do them left to right, as long as you keep the signs with them. And then finally, 6 minus 8, that would be negative 2, plus 2 is 0. Uh-oh. Division by 0, that's a no-go. So unfortunately, this answer is undefined. Division by 0 can't be done. It's an illegal math operation. So the correct answer here is to say that this is undefined.